An enhanced QMMM method overcomes sampling issues in normal QMMM simulation. The sixth QMMM method accelerates selective sampling for the QM region and can capture the chemical reaction pathways without defining reaction coordinate. In this protocol, we successfully captured the chemical reaction pathways of double proton transfer and revealed a deuterium substitution effect on the transfer mechanism of porphycine in water. The protocol can be used to explore halogen or deuterium substitution in heat identification in drug discovery.
The main advantage of the QMM method is that we don't need to define prior reaction coordinates or introduce any bias towards certain reaction pathways when exploring reaction mechanism. The robust sampling enables us to identify possible reaction pathways starting from reactants. The method can be easily extended to high-level QM method and could become an important tool to investigate the reaction mechanism for chemical reactions in solution.
To begin this procedure, initiate the presets by setting run type as 100, temp 0 as 300, temp low as 260, temp high as 1300, and step as 120,000 in the input file. Then issue the appropriate command as shown here. During the presets stage, monitor the energy of each term to calculate the mean values. Use the grep linux command to extract the energy. To modify the average energies in the MD input file, calculate the average energies based on the output of the previous command line.